Hello and welcome to the video demonstration for our final system in PD for the project Chemical Spectral Analysis through Sonification. Here we can see we can have two NMR spectra, one here and one here. To compare, we can add a single comparison mode. Single mode here will just play through our top spectrum. Comparison will play one in each here. We also have an option of two sonification methods. Two of the methods from the initial user test were brought forward. That's the sine wave parameter mapping, design 2, or the spectral modification, which is was design 1. But if I just show you how to sort of navigate spectra in a sine wave parameter mapping, we have our external interface here. And first, if we select the region we want to sonify, so if we just we select the region we want to sonify, so we select this, we can use this far button here to play at a set speed, and then we can stop with this next button here. We can also play through using the scroll wheel. We can play at a variable speed, forwards and backwards, or one data point at a time using this jog wheel here. Okay, now if I want to switch to comparison mode, I can either do that using this switch here, or I can use the button in the interface, and that means we'll get one in each here. These two far buttons here, we can switch to spectral sonification and back. And yeah, that's the basics of how the system works with the external interface. So essentially what the users were asked to do for their final test was take these examples A, B and C and compare the three of them. So if we compare, just say this area, you can hear that this spectrum here is slightly shifted forward from this one, and that's also true if we listen to them spectrally. You can hear that it's slightly shifted. We listen to B. We can hear there that these peaks are slightly different pitches because one of them is these two are actually half the size. If we switch to C, we can see that it is in fact exactly the same. So there we go. That's how we sort of use this for comparison. If I switch back to single mode, we can have a look at how we search for impurities. So you might be able to see here and here we have some very small peaks, and if I were to play through, you can't really hear anything. Now this is tackled using a threshold for impurity detection. So if I bring this threshold down and now play through, you can start to really hear the impurities, so that they become a lot easier to find using this method. Okay, so we also have variable volumes here and mute buttons for each one. You can also change the way that we select using these different modes. We can shift, extend, and expand. And then one final feature of the GUI here is that we have our start point and our end point, and then this is the current data point we're on. Okay, so if we look at a bit more at the inner workings of this, we can have a look at the navigation. So this is very similar to that of design 2. except what we really wanted for this final system is the variable speed and direction. So we have the metro again, but this time it's sort of set by, well, we have it's sort of set to play anytime this is changed, or if we set play. So anytime you change the speed, you set it to play, and then we also send these two numbers off, whether it's negative or positive. If it's negative, we find it that way. We just scale it using this, or we put it into the positive domain using this statement here, just switching the sign around. Or if we press play, we also get it to play through with a 20 millisecond delay. That's the standard play button. And then stop obviously sends a 0 to the metro and it stops playing. We've switched out the counter, which was just a float with an addition, to use the counter object in PD. This has a number of benefits in that you can set the start and end position here. Oh no, set the maximum and minimum using these messages here. You can nudge through it. That's an increment or decrement, which is what we use for the scroll wheel. You can say which direction you want it to go in. So if it's negative, you can send this way to the left. If it's positive, we can send it to the right. It's counting up and down. And then we also can we release a bang every time it gets to the start or the end, depending on which direction it's going. And when it does that, we reset it to the start or end point, and then we just release the data point out there. So that's basically how the navigation works. The interface control is very simple, and it just takes, we have the shuttle configuration here, and it's set to type keystrokes on every button and every position here in the jog wheel. So as you can see, they're all set to type keystrokes. So we just receive the key here, use this little test to see if it's the right key for each thing, and then this set is for scrolling to the right, this is for scrolling to the left, and then this takes all the inputs for the plays and nudges and such, and that sends it back to the navigation patch here. So the actual audio is produced in two patches. This patch, NMR audio L.pd, is used for the top spectrum, so that's used for both single and comparison mode. And we have here is where we use, this is basically for, so this part of the design is for the parameter mapping. So as in design 1, we take in the data point, read off the array, and then we map it to the oscillator frequency. But we also have this expression here, which is used to implement the threshold. So it sets the threshold here with this inlet, and then if it's below the threshold, it gets let through. If not, it's set to 0, and then if it's let through, there's a multiplier dependent on the threshold set to it. So everything below the threshold will get multiplied, meaning that those small peaks can be heard. We also have the mute, the volume, and the comparison switch. Now, if we're switched down to this way, you can see the spectral modification. It just uses the tab play of the NMR signal. We take the untransformed NMR signal in the time domain, and we just play that through as an audio signal, and we loop it using this bang here. So that's a very simple way, and then it's stopped when we switch back to parameter mapping. Okay, so that's the left input. The right output. The right output is very similar. Is exactly the same thing, but obviously the switches are different for the comparison mode. So this will only play through when comparison mode is on, whereas the left input output is always playing. Just occasionally it's only the left hand that's coming out. So if comparison mode is on, this gets set to 0. Okay, finally there's the examples, and this quite simply just sends different files to both the arrays. So that's a very simple patch that just takes in the signal from these radios here and then uses them to select which files are in each of the arrays. So you can see here a bit of a crack when you switch, but that's okay. So yeah, that's the final system. So we've got the parameter mapping, spectral identification, comparison and single. We've got the threshold for detecting impurities, and yeah, our nice little area selection bar here. The credit for that goes to Mike Moser Booth, I believe is his name. Yep. From the PD forums. This is part of some externals that he made, some abstractions he made for a waveform display. So we've used that for our area selection, and it works very nicely. The only edits we've made to this is to send out our start values. So yeah, that's the final system in PD. Thank you very much for watching.